Good morning. My name's Colin. I'm a Senior Systems Engineer at Juniper Networks, and this is going to be a bit longer than 5 minutes. It actually seems to be the case with some of my recent videos. Today we're going to be talking about failover, specifically how to replicate some of the behaviors you might see if you're used to ip-sla in Cisco iOS, and how we can kind of accomplish some of the same things in Junos, and how the way we accomplish those while seeming somewhat more complicated on the surface, I think is actually pretty cool because we have a lot more flexibility. I'm going to get into that here in a minute. So let's start with the environment. If you watched my videos before, you should be pretty familiar with what this looks like here. We're going to be testing a branch location here. In this case, I'm simulating that with this SRX cluster of 340s down here. It's in the center of the screen, I should say. And we've got 2 connections. I've got an MPLS fabric that is built between that SRX cluster and this VSRX1 in the upper left-hand corner. That is going to be kind of our pseudo core. And then I have a simulated connection to the internet, essentially a router. This does have connectivity to the internet from both the VSRX and the SRX cluster. And there's an IPsec tunnel that's built over that. We're not really going to be looking at the IPsec tunnel today because that's not the use case for the testing we're doing. But we have kind of what I like to think of as a pretty common core branch enterprise configuration here. So what do we want to see? Well, under normal operating circumstances, your CorpNet traffic is going to be going over this MPLS fabric here in the middle, and you're going to be doing local internet breakout from your firewall device here because you don't want to carry your internet traffic over your expensive MPLS link. Now, if the internet circuit goes down, then you're going to want to swing that internet traffic over to this MPLS link so that it can then come out this VSRX, your core, and get out to the internet still. And then when that service is restored, you're going to want to swing that back and go back to your local breakout. Now, the Cisco device, you use ip-sla, and with a Juniper, you can use dynamic routing protocols. If you wanted to build like a GRE tunnel between this VSRX and this SRX cluster. But all that would do is really get you path to your core. You can game that a little bit to do some local breakout, but if you're going to advertise a default route, well, you're either going to have to grab one from your carrier, or you're going to have to build a some sort of trigger that can identify when that link goes down, and then swing your connections over. Now, in Cisco world, you do this with ip-sla, and you basically attach a track to a route, and then when a behavior is met, that track can pull the route. It can change its metric and make it less attractive so that some other route takes over. There's some behaviors you can build in here. And the consideration that we have on Junos is that we can't pull a route out with the IP monitoring service. So we would use a combination of like a RPM probe, something where you could generate ping packets and test keep alive to a specific destination across that internet link. Because you might not, the link might stay up and the internet might be inaccessible. So you want to make sure that you're actually testing connection or connections to something out that link. The IP monitor function that Juniper has that configures with the RPM probes will allow you to add routes. But if you need to pull a route, we've got to do that a little bit differently. So how do we do it? Well, in this case, we use an event script, or I should say it's event option in the config. What is an event option? Well, an event option allows us to trigger an action based on a syslog message. So if I go here and show event options, these are the ones that I have configured here. I've got 2 dead canaries and an alive canary. The dead canaries are monitoring a probe, and I'll show you that in a moment, that is checking on the health, reachability of 2 different IPs that are out through the local internet breakout, and it will basically pull the default route if both of those become unreachable. The event that it is triggering off of here is called ping probe failed, and this is something that kind of tied me up because kind of the ADD engineer brain, I'm looking at this process and I'm reading the configs hoping to sort of divine what they're doing, and it took a little while for me to realize that this is actually just, you find this in the syslog. So any log message that you have, you can actually build a trigger off of, which is why I think this is kind of cool. Because ultimately this is what ip-sla on iOS was doing under the hood, but we've exposed more of it, which means that you can build more functions. You can basically build events around anything that you see in the log. Now, you don't have to be able to be viewing these logs in order for these to work. So the very, very first thing, if you're going to do this, that I suggest you do, is go into your syslog facility here, syslog, and create a new file. This is going to be the name of the log file. So in this case, I called it events, and configure daemon any. I also configured conflict log any because this will tell me if there's like commit issues. And these match statements are actually filters because not everything in the daemon, the local daemon, is going to be something that I actually want or need for the purpose of my failover. So this is just sort of to edit out some of the cruft. So this daemon log here, so we're at the file events. If I were to run show log events, you'll see that this shows the results of the RPM probe that I have configured. So let me show you that here. Show services RPM. So I have a probe called canaries, and then I have two canaries. They're basically DNS servers. Canary 1 goes to all 8s, canary 2 goes to all 1s. And you can see from the event log here, you can see some fails. This is just historic because I've been running this for a while. Here's when I've done testing. But when this is running in a normal, healthy state, we'll see, ping test completed. You have this owner index that names the RPM probe, and then you'll have this test name that names the test in the RPM probe. So in this case, we have, we can tell that the RPM probe canaries ran the test canary 1, and that test was successful. And if we go back and we look at our event options, we'll see that we have this, and we'll look at the alive because we're in a normal state. So we'll see that ping test completed, what we're looking against, and we have test owner matches canaries. So once I put that together, I was like, oh wait, this makes a whole lot of sense. That's pretty straightforward. I see something in the event, then I define an attribute match. So it looks for that event, and then it says, what's the attribute within that event that I need to match against? And when it finds that match, it executes the action that you define. So let's get into the action that I've defined here. Now, since I have to fail this over only when both of those destinations are unreachable, I had to create two event options here. So kind of scroll past here. And the reason I had to do that is because I need to make sure that there's a sequence where if I see that one has failed, I need to check to make sure the other one's failed. And since I'm not going to know which one may have failed first, I have two different policies here. The first policy will check to see if if it sees a message for canary 2, it'll check to see if there's a failure for canary 1. And then the second one's just the inverse of that. And the way that we do that, you can see that there's a different piece of config down here for the alive canary, is that we use this statement called within. And if you're looking for how to configure this or what the options are, you'd be looking for event options correlation. Correlation is the term that we use. And this allows us to define a kind of an if-then. In this case, I start by saying ping probe failed. And then I define using $2 the initial trigger statement. In that case, that starts this process. So essentially I'm saying, hey, if you see something in the log that's under test name and matches canary 1, now you're thinking, now you're watching. Now within 10 seconds, you see one of these failures here, then you need to execute this action. So I've said, wait 10 seconds, trigger when you see this twice. So this is a 20-second thing. So it requires 2 triggers. And this is some tunability here. The consideration is you don't want to flip these paths, if there's just a momentary outage or if one set of probes has been missed. I don't know, maybe you do. So that's more of a technical consideration, but once everything's put in place, you can play with these numbers. The consideration there, though, is make sure that your within time is going to kind of match up with your RPM probes. So my RPM probes are running every 3 seconds. So triggering on 2, you can get these numbers wrong such that you never have a match condition because your RPM probes are running, over a longer duration. So that's where the tuning comes in. This also means that when this does fail over, it can take maybe about 20 seconds. And the other thing to remember is this is a commit. I am actually telling it to enter these commands into the configuration, and then there's a commit. So the whole process takes about a minute. And again, there is some tuning you can do around that, but that's it's commit. Kind of neat though, when it does the commit, you can see kind of the behaviors here. So if either of these policies is triggered, which, this is just a sequencing thing. If one of the uplinks dies for the other one, it's the same behavior. It does the same thing in both cases, and that is to deactivate the default route that I have, which means the only default route that is left is the one that I'm learning via BGP that goes to this VSRX here in the bottom left. To activate a pair of routes, these are the destinations that I'm pinging to, and this is just so that I can continue to pin my test to that next top gateway. Remember, this will be unreachable, so the things that you're testing to, you need to make sure are things that you don't need to access normally. So make sure that your canaries are really just canaries. They're not like services, because if they're services, then you probably want them accessible. And if they're accessible, then you're probably going to want to leave the routing alone and kind of let the protocols do what they do. I'm going to activate this alive canary script down here. You can see that it's inactive in a normal state. And this is essentially the thing that is checking and bringing everything back to square one when the pings are successful again. And then I'm going to deactivate these two events. And the reason I'm deactivating them is because as soon as that failure occurs, I need these to make your routing changes and then turn yourself off, because I don't need you trying to detect if the link has gone down. If the link's currently down, I just need this running to make sure the link when it comes back up, the routes get put back in. And you can see the behaviors that are defined down here are just the opposite of what I did right up here. So, all right. And if we look at our routing options, you'll see the routes that I'm talking about. I've got two that are inactive and one that is active, my default static. And then just look at the RPM probe one more time. My canaries, I've got 3 probes, run 3 probes at probe intervals every 3 seconds, which means that this takes 9 seconds to run completely. Which means that that's why I set this to 10, because if I set this to 7, hey, guess what? This probe would run, it would take longer to run than the trigger that would actually trigger this behavior. All right, so, hey, do some testing. So right now, if we do a show route, our default route, we can see that we have the static here. And if I were to, let's say, do a trace, ping google.com on that. Hello? There we go. All right. All right. This took a second to get kicked off there. And if we look at what we'll do is we'll look at the path here too. And actually we'll do that up here in the upper left-hand corner. So this Pi 3 here, this is this test machine in the bottom left-hand corner. So we'll just start and kick off an MTR. Did I not click on you? Okay, there we go. Kick off an MTR. And we can see that the path is just this local path. This 10.0.20.254. I'm natting so that when my path switches, I have return path. I don't have to worry about pinning statics in my core firewall. But that's this interface right here. So that's why that ping doesn't go all the way out across the internet, because it gets natted. But that's not what we're interested in. We're interested in seeing this path change right here. So that's working. That ping works from here. And ping Google, no problem. So great. So let's leave the MTR running in the corner. And we're going to go through a couple behaviors here. So I'm going to go through a monitor, start, events. And we will see the successful probes running as they go. Canary 2 and Canary 1, we can see ping test completed. It doesn't say success completed, just means it worked fine. And this will just repeat on the probe schedule. Now, what I'm going to do is I am going to enable a filter that I have running here. And this is going to filter to, I think this 1.1.1.1, this is Canary 2. So as soon as I enable this, I believe we're going to start seeing Canary 2 come back with ping test failed. And what we're looking for here is actually nothing. We're looking to see that the ping test failed. We can see it did right there, but we don't. This shouldn't trigger a failover event because, again, remember we've written these event options such that the that failover, the action, only occurs if both of these are unreachable. So we can see that one has failed. We can see this other, other one continues to complete. We show route 0.0.0.0. can see that nothing has changed. And we can see this tracer out has not changed either. So that is exactly what we expect. Great. Now I'll go ahead and disable this, save, and we'll see the ping test completing again. And I'm going to go ahead and turn on the other filter just so that we can demonstrate that if we flip the behavior and canary 1 is failing, canary 2 is working, we still don't see a failover. And we can see that they're both completing again. So we'll go here, basic, enable, save, and then after that, we'll have them both on at the same time, and that's when we should see our failover. So, ping test completed, and there's our first failure. We see canary 1 is failing, we see canary 2 is running, and remember, we got to give it 20 or 30 seconds. I'm not going to wait that whole time, trust me, it works. But when we do the final failover, yeah, we expect it to run about a minute before we see the actual path flip. But in this case, yeah, nothing's changed, everything's fine. So now let's go ahead and turn this filter on. This should trigger our failover. So what we'll do is we'll see both of these coming back as failed. We won't see these ping tests completed anymore. There we go, canary 1, canary 2, both down. I'll move this out of the way so we can watch this tracer out, because this tracer out you'll see the MPLS path. I don't have my MPLS core configured to hide the label switch path routers, just because it's useful for me to be able to see this information. Yeah, this isn't production here. We're having fun. So we're just going to keep an eye on this and keep an eye on this. You can see that it's just triggered the event's actually starting to run here. That's the UI child. And we should see a commit, expected in the next 10 or 15 seconds. This path will flip over. And we'll see the commits here. So if you're watching this event, and you're testing this, just do a monitor start, and then you'll see that commit take place in this log stream here. Boy, I'm a little tired. I thought last night, great night, just calm, relaxing evening watching a Blazer game. And last night, game 3, playoffs, second round, and 4 overtimes. That was exhausting. And somewhat amusing. As I came home and my wife said, was that relaxing? I was like, yeah, sure. It was 140 to 137 and 4 overtimes. Only the second time ever. All right, hey, look at that. So we can see that our path has flipped over. And we are now going out to the internet. And I'll go ahead and change this. There's our commit over here. I'm going to go ahead and just start that over again, just so I can clear out the loss. But we can see that this has flipped our path over. Now, if we do a monitor stop, what we expect to see here is that our default route is only learned through BGP. Ping google.com inet. You can see that we can still reach the internet by just doing it through that MPLS connection. And if we go and look at the configuration, we should see that the 2 dead canaries should be disabled, and they are inactive here. And we can see that this alive canary, which is doing the, this is the behavior when those links come back up. And remember, only one of them needs to come up for this to be restored. That's why we're just looking at ping test completed, not specific tests like we are up here. And then we should also, if we look in the config, we'll see the routing options. We'll actually see that the default has been deactivated, and we've activated these 2 for our canaries. So let's restore service. And the way we'll restore service is we'll just restore one of these. And we'll say save, and we'll monitor start events. All right, and you'll note that we haven't really touched the VSRX. I've got it running in the bottom left-hand corner. All of the things that we're doing here are just configured on the branch side of this connection. So I have that there just in case I needed to poke at anything, but it doesn't care. It's just processing traffic that it receives, and in this case, there's just a little bit more because the internet traffic is swinging through it. So we can see that our ping test for our canary 2 is now succeeding, And from a customer standpoint, since this behavior now is additive, since we're just adding an internet, local breakout back in, it'll be minimal disruption. When the link goes down initially, and we have to go through the process of consuming the probes and then creating the commit action. People that are connected to the internet are probably going to feel that during that period of time where the link is something's happening and we haven't swung everything over to the MPLS yet. But when we're going back and it's just additive, their path will change. They might actually have some sessions that flip just because if it's that path changes the address that they're natting from, they might have whatever they're doing reset. That's it. There is our commit, and actually I saw this just change, so yeah, we're back to where we were. Done and done. So monitor stop, show route, back to local breakout, and google.com. And then I know you're going to work. Yeah, there you go. And if we look at our configuration events, we'll see that our dead canaries are active again, and our live canary is not. So that's how you can simulate it. And yes, it's a little bit more typing than the ip-sla, but essentially what we've done is we've taken what ip-sla is doing in the background and we've exposed it to the user so that you can actually be far more articulate with it. That might be a plus for some people. I know for me it's really interesting, particularly since this architecture allows me to, now I'm thinking about all the other neat things I can do, actioning off of, things that are happening in the syslog. That's pretty neat. I know that these events, you can actually build, on-box scripts that you can trigger off of these events. So if you see something happen on the syslog, you could actually tell a Slack script to go do something, right? So it's pretty cool. And once the framework's put in place, I think that, you can make tweaks. I'm going to send this config to somebody this morning, and the tweaks are really just going to be change these values and, change the values in the routing options and paste it in and change the RPM, just find your targets and define them in the RPM probe, define them here, leave everything else in place, done and done. So yeah, straightforward. That's what I like to tell people. Don't use the word easy. Anyway, if you have any questions, please put them in the comments. I'd be happy to answer them. I like putting these videos together. And have a great day.